Want to build this? I promise it's not vibe coded. Let me show you how. Hi, it's been a while, 4 months actually. I've been cooking something big. Today, not only are we building a mini axe throwing game together, but I'm also releasing a brand new chapter in my React 3 Fiber course. All about particles, trails, VFX, Web GPU and TSL. Get 30% off with Wawa VFX code until April 15th. To celebrate, I'm releasing the VFX engine we built in the dedicated lesson as a free NPM package called Wawa VFX that makes adding visual effects to your React 3 Fiber projects very simple. In this video, I will show you how to use the package by building this mini axe throwing game. I have prepared for you a starter pack for this project, including a few models and assets. The link is in the description. Let's clone it. Code, copy the URL, and in a terminal, run git clone, paste the URL, and I will type a folder name, r3fx final. Once cloned, you can open the folder, open, and before having a look at what it contains, yarn to install the dependency or npm install, and yarn dev to start the development server. Follow the URL, and this is what you should see. We have a simple UI with my logo and the name of the project, Training Center. We have a cube in the middle of the screen, and you can see that Bloom is enabled on the project with post-processing effects, as well as a grid for the floor and a gradient for the sky. I have included a few assets in the project. I will present them to you while we code the project together. Because our game is about throwing axes toward a target and balloons, let's start by our axe and throwing it. Let's open the source, components, and experience file. This is where we will code the main logic of our game. For a bigger project, I would recommend you to split into different files, but here, for a matter of simplicity, we will do most of the things here. Next, to gradient sky, let's create axe controller. It will be the component responsible to contain the axe, to be able to move it and to throw it. And let's create this component, axe controller. To render it, we can use the gltf component. The source will be models/axe small.glb. You can see that it's one of the models here in the starter pack, and it's one I found on poly.pizza. If you type axe, you have different models. You can choose between them. You don't have to follow exactly the one I used. I think mine is this one from the legendary Quaternius. All right, if we reload, we can see the axe. It's because our camera is very centered and the axe is at the same position as we are. We will adjust that later, but for now we will need to add physics to be able to throw our axe. To add physics into our project, we will use a React 3 Rapier library, a wrapper around the Rapier physics engine. If you are new to this, you can check my course lessons dedicated to physics, or check one of my free tutorials available on YouTube. Let's add Rapier, yarn add at react-3/Rapier, and let's type yarn dev, so it will be ready. It's good. The main entry point for our project is the experience. So in app.jsx, we can wrap the whole experience into physics. Let's add debug for now, so we'll be able to visualize the different colliders. And also, colliders is equal to false, so it won't by default add colliders to our rigid bodies. We will create them ourselves. All right, now we can go to the experience and axe controller and wrap our gltf model within a rigid body to add physics to it. We can give it a name, axe, and colliders, we will choose a hull. Think of it as a wrapping paper for a gift. It will wrap our object, our axe. Now, if we reload, we will see that the axe is falling down directly. This is because it's impacted by gravity. We don't have a floor, so it will fall infinitely. Until we launch the axe, we want it to be of type kinematic position. It means we will control its position. Once we launch it, then it will be dynamic and respond to physics. If we do this, we can see we have our axe, and you can visualize the colliders wrapped around the axe. It's not perfect because we chose the hull, which is simpler than the tree mesh one, but we don't need the detail here of this hull covered. Now let's add that when we click on the screen, it will throw the axe. For all our game logic, we will create a main store using Zustand library. The simplest solution to have a global store while being performance efficient. Here you have the basic way to set up yours. We need to add Zustand, yarn add Zustand, yarn dev and hide the terminal. Let's create a new file. Inside source, we can create a folder named hooks, and we will create usegame.js. Let's create a very basic one. Export const usegame is equal to create from Zustand. Then we will have access to set and get methods. Get, and we can return our store. For now, we will just have a boolean. Axe launched, it will be false by default. A method launch axe. What it will do is set axe launched to true. And then let's say 2 seconds after, in a set timeout, we will set axe launch to false. Either it will hit the target or fall anywhere. We want that after 2 seconds, we get it back into our hand. Now we can go back to our axe controller and have access to both of them. We will have axe launched is equal to usegame of axe launch and launch axe usegame of state.launchAxe. Now inside a use effect, we will add an event on pointer up, and we will call launch axe from our store. And we add event listener on our document on the window. We listen to pointer up event. And when we return, when the component is unmounted, we remove the event listener. Now inside a use effect, when axe launch change, let's console log it to see if it works. So what do we get? Axe launch is false. It's called twice because we are in development mode. Now if we click, you can see axe launch is true, and 2 seconds after, it's false. Perfect. Now we need to apply some force on the rigid body when we want to throw our axe. We need a reference to it. Let's name it RB for rigid body. And let's create a reference with useRef. Let's quickly see what we want to achieve. We have our axe, and we will have the target on the right on the x-axis. We will send it to our right on the x-axis, but we don't want to just push it on the x-axis linearly. What we want instead is to create some kind of realistic movement, which is to push it on the right and a bit upwards. Then the gravity will do its job, and then it will reach the target or anywhere if the timing is wrong. And to make it even more realistic, we will also apply some kind of rotation. So you can see that the axe will follow and do multiple turns before reaching the target, like a real Viking. And as always, my end drawing looks bad. Let's apply those forces on the rigid body. First, because we are in kinematic position, it won't be affected by gravity and by the power of our launch. We need to change the type of our rigid body. If axe launch, we set the body type to 0, which is equal to dynamic. Here inside rigid body type, you can see the different value for them. Because we are not using TypeScript, we can't import the type, so we need to use the direct value. Then we need to apply an impulse. We push it to the right and a bit upward. And then we apply some rotation with a torque impulse with a Z rotation. Let's try it. We throw it. So we have a nice movement, but then it's never going back. To make it come back, either we can use axe launch and set back its default position, but because we want to animate it with our mouse cursor, let's do in useFrame. If we have rb.current and that the axe isn't launched, we will need to have access to the mouse position with pointer from the callback from function in useFrame. and rb.current.setTranslation and the x, y, and z value we want. Now it will follow our mouse position, and if we click, it will throw it. And after the timeout, it's coming back, but it's still rotating. For that, we can disable all the forces with set rotation, set lean-vel, and set hang-vel. This way, it will stop moving. We will need to import the quad from Rapier. And let's try it again. We click, and it's coming back and stopping its movement and rotation. The axe is a bit too high on the screen. We can say position y is equal to minus 0.3. It's a bit better now. All right, let's replace this cube with the target. Let's go on the top of our experience, remove the mesh, and we will have a target component. And let's position it inside a group. We will set it at -1 for the position y and position x 20. Now let's create our target component. First, we load the 3D model with GLTF, the model we are using, and we adjust its position and scale. Don't forget to do the imports. And the model is something we prepared. You can see in public target texture. You can see it's some kind of ancient runes target. It's a bit like a rune with a W for Wawa Sensei. All right, it's in front of us and it's blooming nicely, perfect. But we want to be able to hit it. To be able to detect the collision, we will wrap it inside a rigid body. The collider will be hull. The type will be kinematic position. We want to be able to animate it, to make it move. Let's add a name. So when we have collision event, we can identify with which object it happened, and a reference, same RB. Const RB is equal to useRef. In a useFrame, let's animate it. We will need to access the clock. Then if we have a rigid body, we will set its translation to a vectory of 20. Then we will make it move up and downward with math.sin based on the time multiplied by 2. So it will go from 2 to -2. Vec3 need to be imported from Rapier. We can now see it has colliders onto it and it's moving. Let's try to throw our axe. It hit it, but then it fall. Let's go to detect the collision inside our axe. On the axe here, we can use on collision enter. We get the event inside the callback function, E. Then if the other rigid body object is the target, then we will set back the body type to 2, kinematic position. We will stop its movement with the linear velocity and hang velocity. Let's try it. We throw the axe, and you can see it's stopping once it hits the target. Now let's add an explosion when we hit it. For that, we will use my VFX engine. This is the one that we built together in the dedicated lesson inside my React 3 Fiber course. But the library is free, so anyone can use it, even without following the course. You can learn how to use it with the different examples and the documentation written here. Let's add it into our project with yarn add Wawa VFX, yarn add Wawa VFX, and yarn dev. Perfect, it installed the latest version. Now how the library works is there are two components. The VFX particles that you define at the top level of your project that will be able to render one type of particles. And then anywhere you want to spawn particles, you will use a VFX emitter that can take different settings to spawn particles inside the main VFX particles. This way you only have one render call for hundreds of thousands of particles. Does it look scary? It isn't at all. Let's go inside our experience next to environment. Maybe after we can organize it with our VFX. We will have other ones later. And we use our VFX particles component. We add a name to it. It's very important. It's in the other component. We will use the name to spawn particles. Then the settings. Fade alpha, it means it will start to fade in at 0. So it will be directly the full value. And fade out at 100% of its lifetime. which means you won't have any fade in, fade out with those settings. Then fade size, it will be directly at full size, but starting from the beginning, it will start to fade out for the size. Then we can add some gravity, something close to the gravity on the Earth. Then the intensity of the bloom, the number max of particles. It means you can have 100,000 at the same time rendered. While you can still spawn 1,000 per 1,000, just know that the maximum that will be rendered will be 100,000. And then the render mode, billboard, so we will have particles always facing the camera. Okay, now we will want to spawn those particles where our axe hit the target. Inside the on collision enter, we know that we hit the target at this position. Let's create an impact state. Use state, it will be false by default. And then on collision enter, we will set impact to the current position of our axe. Or we could also use the point of collision with the target, but in this case, we don't have to be precise. Now next to our rigid body, we can check if we have an impact. Then we can use inside a group, the position will be equal to impact.x, impact.y, and impact.z. And inside we can render particles. But first, let's see how to set up particles. Let's do it outside the condition for now. Let's use a VFX emitter. And the emitter, it needs to be the name of the VFX particles, sparks. Then you can use the debug prop. Now if we reload, we have particles. I need to zoom out a bit to see them. And you have controls to fine-tune the shape of them. Let's say we want the explosion. What we will need to do is to spawn them not about time, but in burst mode. Let's try it, restart, and we have one big explosion. Maybe what we want to do is to add multiple colors. I'm hiding the controls. Now it's better. Let's say 2. One will be red and the other one will be white. You can see we have both colors. You can adjust their size to something maybe smaller until 0.3. Fine-tune the explosion the way you like. And once you are happy with it, click on the export button. Then you can replace debug with settings and paste what you had in your clipboard and save. If you reload, the settings will be good and you see the explosion. If you don't find good looking settings, feel free to copy the one from the final project, which are mine. And now, instead of spawning them at our position, we will do it conditionally inside the impact group. Let's try it. If we throw the axe, then we see the explosion. But if we try again, we won't see it again. This is because impact isn't reset and it's not spawning the burst again. A quick way to adjust it is else set impact to false. So when we get back the axe into our hand, we set the impact to false. Let's try it once. I missed it, so no reason to explode. And not again. And this is because I didn't save. Should be better now. Let's hope I first shot it once and twice. Perfect. Time to add some balloons. Inside the project, you will see a model named balloon modified. Go to texture, you can see it's a balloon, but it's branded Wawa Sensei. Guess where I found the original model? On Polypizza, balloon, and I think it is the one from Poly by Google that I then polished inside Blender. First, we need to spawn the balloon. We will do it inside our use game. We will have an array of balloons. Let's add a start game method. It will call set the balloons. It will be a new array of 50 balloons with, for each of them, an ID. For the React key, it needs to be unique. Then its position, we generate a random X, Y, and Z value with a run float from 8 to 18 and run float spread from -1 to 1. Don't forget the different imports. As we also want to customize their colors on the fly, we can create an array containing all the different colors feel free to customize it. Now we can prepare some reusable materials for each color in a balloon materials. For each color, we will create a mesh standard material using the appropriate color. And now when we create our different balloon, we can add also a random color from our array between the index 0 and the number of balloons, so either one of the three. We need to connect the start game method inside our UI. Let's do it. Inside UI component, we can import start game from our store, use game. And simply on the start game button here, on click, we call start game. Now inside the experience, we will want to render all our balloons. We can find the axe controller. The file is starting to be messy. And balloons. Now we create a new component named balloons. And we get access to them from the store. For now, we can just console log to see if we have. Now if we try, our array is empty for now, and start game, we have an array of 50 balloons. They all contain a different ID, color, and position. We know we have the balloons here, we just have to render them. We can return balloons.map. For each balloon, we will render a balloon component we will create together. The key will be balloon.id, and we pass the rest of the props. Now below, we create our balloon component. We will have access to its position and color. We won't use the GLTF component here because we want to be able to change the color of our mesh. On gltf.poimaddress drag and drop balloon.modified. This website, it is the gltf JSX online version, and we will get the code to load our balloon with the different meshes it contains. Let's copy it, and don't worry about the preload here, as it's something I already made in the starter pack. Check the course if you want more details about what it is about. Now inside our balloon component, we can paste what we got. Use gltf. We need to type the whole path models/balloon modified. We can disable shadows because they will be expensive for no reason. Then we don't want to use a group here, but a rigid body. And for the materials we use, instead of using materials.color, we will use balloon materials of the color of the balloon. This way, it will be the reusable ones we created earlier. For the position of the balloon, let's assign position. Let's try to see if it works. If we press start game, well, it's throwing the axe, we will need to disable it later, but we can see we have different balloons here. And then we need to make them fly up. The type of our rigid body will be dynamic. We want them to be impacted by the gravity. To make them like helium balloon, we need to set the gravity to the inverse, minus 0.1. And then a light mass, some linear damping and angular damping, which will slow down their movement and their rotation, and the restitution, so they will be able to bump between each other, like real balloons. Perfect. We will also need a reference for it. Const rb is equal to useRef. And for the collider, we want it to be only on the balloon part, not on the string that is below the balloon. We want to use a hull collider, but we can't use hull here because it will apply to all the different meshes. We will create it manually with convex hull collider, and the argument it takes is the geometry we want to apply it to, which in our case is nodes.balloon.geometry. And by browsing the code of our React 3 Rapier, I saw we need to use attributes position array. Now you can see that the balloons have a collider and they are floating upwards. They look a bit too small, so let's wrap everything into a group and we will scale it up. Scale is equal to 3. Let's try it much better. And what happens if we throw our axe? You can see it is impacted by the balloons, which is a big issue. To avoid this, what we can do is on our axe, we switch it, the rigid body, into a sensor type. If we do that, start game. If we throw it, it goes through the axe, but the collision is not detected anymore. It's because for a sensor, you need to use on intersection enter. And with on intersection enter, you can have the exact position, the point where you have the intersection. That's why we are using the translation of the axe for the explosion. All right, let's try it again. Start game. You can see it's exploding. And if it goes through balloons, it's fine. We just want to make them explode. On the balloon, let's detect the collision with the axe. We go to the balloon component. And in on intersection enter, the right approach here is to use on intersection enter to declare yourself a function in a use callback. Is equal to use callback and then to code your function. Because on each re-render, if you don't do that, it will recreate the rigid body because one of the prop changed. Now, if the other rigid body is the axe, then we set exploded to true. Let's define our states, exploded and set exploded. By default, it's false. And for now, if it is exploded, we will set the balloon to be invisible. So it's when it's not exploded that it is visible. Let's try it. Start game. And when it touches the balloon, you can see that they are disappearing. Now what we want to do is to trigger some sparks, some explosion every time we hit a balloon. Inside our rigid body, if it is exploded, then we add another emitter. We use the same sparks particles because it's also some kind of explosions, though the main aesthetics of the VFX particle sparks is good. And then you can define different settings to what you like. Just note that for the colors, I'm using the one from the balloon. This way, a pink or a purple balloon that explodes will have a pink or purple explosion. All right, let's try it. Start game. Throw it, and we have nice explosions when we hit the balloons, but it's a bit hard to hit them. This is because we are playing from left to right, but the balloons, because they collide with each other, they are a bit either on the left or on the right. This is something we will need to adjust, but first let's add them an initial movement. In a use effect, when they spawn, if we have our rigid body set, which should be the case, we apply a torque impulse to add them some random rotation at the initial spawn of all the balloons. Let's see what we get. It's better, you can see they are rotating, but they are spreading even more. This one on the right, we will never be able to touch it. To do that, let's add some invisible walls. Where are our balloons? Here, we will add a walls component. It will be two planes on the left and right, and that will block them to go further away, to stay in range of our axe. Let's create them. Const walls. And inside, we simply return two rigid body, one on the left with the Z position, because again, we are looking on the right and using the x-axis for the depth, and a cuboid collider, a thin one for the depth of the wall, and the same for the opposite side, left and right. Let's try to see if it helps. Start game, and you can see that they stay in the middle always. We can throw it and it's easier to hit them. If we zoom out, you can see that you have the big walls here that restrict their range. Something else we can do is when the balloon disappear on top, we make them reappear below. Let's do it inside our balloon component in a use frame. If we have our rigid body and it didn't explode, then we get the current translation for this balloon. If it is above 20, you can adjust it using the screen size or any metrics you want. Then we generate a new translation Y between -20 to -15 below the ground. We also need to stop its movement and angular velocity. And like we did at the spawn, we apply a random rotation, a new one. And then we set the translation to the new value because we impacted it here. Let's see if that works. We have balloons, they are disappearing upwards. Are they coming back? Yeah, we can see they are teleported. They are a bit jumpy. Maybe it's because of the debug. And then they are here again. Perfect. We can continue to play. It's going well. We can disable the debug to stop seeing the colliders. And when we throw our axe, we will want to move the camera to better see whatever we hit. Let's go to app. We can disable debug here and change the default camera position. This one will be when we want to throw an axe. Instead, use the starting one to be 0, 0.5, and 10. Adjust to what you like. And inside experience, we have a camera controls component to be able to animate the camera. We can get axe launched from use game. And in a use effect, when it changes, if the axe is launched, we animate our camera. Here it's its position and where it's looking at. And then if it's not the case, we will set our camera. It's when the axe is in our hand to what it was before. Let's try it. We can click on start game and you can see the camera is animated. We wait for a few balloons and the right timing and perfect. But we still need to adjust many things. First, let's count the score. We want to get some points when we hit balloons or the target. And we also want to have a maximum number of time we can throw the axe. So all of this logic, it will be in our use game hook. We will need to add a few properties. First game set to true by default, so we can polish the UI based on that. Balloons hit, target hit, and the number of throws that we have available. Let's handle the logic of all those variables. So when we launch the axe, what we want to do is to reduce the number of throws. So throws, it will be the number of throws minus 1. And we want to do it only if our axe isn't launched and if we still have throws. If not, we won't be able to launch it. Now, when we start the game, we need to do other things than just spawning the balloons. We want to assign how many throws we can do. Let's say 3, but adjust to what you like. Axe launched will be false. First game will be false. So as soon as you press the button, it's not the first game anymore. And we reset the score. Balloons hit 0 and target hit 0. Perfect. Now we can add 2 methods. On balloon hit, when a balloon explodes, we set the number of balloons hit to the value +1. And same for the target. Very easy. Let's prepare our UI to take these new data into consideration. UI. Here we need to access all of them. We have balloons hit, target hit, the number of throws, and if it's the first game or not. Now inside our UI, we want to display this big block, training center and start game only if we don't have throws anymore, which means we need to start the game. So if throws is equal to 0, then we render this block. And then on the top right of our screen, what we will do is display the number of axe we can throw. So based on the number we have, we render an emoji containing an axe. By using saturate 0, we have it in black and white. Then if it's not the first game, we will display the score. On the right, we'll have the score. It will be a calculation of each balloon will be 5 points and target hit will be 50 points. Feel free to adjust to your game mechanics. And then below, we simply show how many balloons we hit and how many targets we hit. Let's try it. We can press start game. It's not throwing the axe anymore. And now we see we have 3 axes on the top right. If I click, I only have 2, 1. And if we press again, we have back the button to start a new game, and we can play again. Perfect. For now, the number of balloons and our score were 0 because we don't handle the call to the method to update the score. Let's connect it. Where we have the impact for the target, we can simply do on target hit from use game, and in a use effect when impact change, if we have one, which means we hit the target, then we call on target hit. I'm doing it here because if I do it on the collision, there is a risk that it's triggered multiple times. And same for the balloon, exploded, set exploded to true, because it can be impacted multiple times. We will also do it in a use effect. So balloon hit from our store. Oh, but this is the number of balloon. We want to call on balloon hit, and simply in a use effect when exploded change, we call on balloon hit. Let's try it. I'm not the best player of my game, but I will do my best. We hit a few balloons and then the target. Let's try again. And I only hit the target. You can see the score is updated accordingly. All right, let's add some polish. First of all, we have all our background. This is Ancient Runes-V1. It's a model we prepared by following one of the tutorials from Polygon Runway. He has free content on YouTube, but he also has some courses. You can see this is the one we are using here. If you want to grow your Blender skills, his courses are amazing. Let's load it on our main component. Up to the grid, we add our ancient runes with shadows. We scale it, rotate it, and position it. Perfect. Adjust to whatever you like. Now it's way more immersive. We can start the game, we throw it, and we have the nice staging. And you can see that the balloons, they are hidden by the stage here. For better immersion, we can add some stars. And for that, we will simply use the Wawa VFX engine. Next to the other VFX, we add a VFX particles component named stars. And instead of using the default geometry, which is a plane, a square, then we use a circle geometry. We assign different settings for a different effect from the one from the billboard. And because we don't intend to spawn so many of them, 5,000 maximum should be enough. This one, it will be spawned at the very beginning always. So we can add another VFX emitter just below. VFX emitter, and the emitter is stars. It needs to be the same name. And then adjust the settings to what you like. Me, I made them spawn between -20 to 20 with long lifetime, a very slow speed to still have some movement, but very subtle. To always have them on screen, I set loop to true and spawn mode to time, and a duration of 10 seconds, which means we will have 5,000 particles that spawn in 10 seconds. Then different colors, different sizes, and it's very subtle, but you can see you have a few floating stars on the screen. Maybe adjust the effect to more particles. Now what we will want to achieve is when we throw the axe, that we can see a trail following it for a better effect and to visualize the direction it took. For that, we will create another type of particles. Let's copy paste. We will name it axis. It will need a custom geometry. We will see what we use, and we will use different settings. Fade alpha to 0, so it will directly fade out. Then fade size, we don't want to impact the size. The gravity, we don't want gravity, so we can just remove it. The intensity to 2. And we won't have a lot of axes because it's only the trail for one movement. So 200 should be enough. And very important, the render mode, we need to be mesh because we will need to render our custom geometry from the axe model. To get access to the axe geometry, let's see how it works inside gltf.poimaddress. You can see that for this mesh, we have 4 different meshes because of the different material. But our VFX particle will be only able to use one of the geometries. For that, I have prepared an axe small applied that merged all the geometries with only one material. that we can use for our particles. I explained the process in my course inside the Wizard game lesson, but you have the model ready for you in the starter pack. Let's get access to the nodes with use GLTF. Here in the main experience, nodes materials, we only need the nodes. And the correct path is models/axmol applied. Then we will need the geometry. And here for the axis, it will be a primitive. Object will be our geometry. Excellent. Now we need to spawn them inside our axe controller component. Here it is. Let's do it simply. Inside our component, next to where we spawn the axe, so we are sure it's in the same position. What we need to check is if the axe is launched and we don't have an impact, because we will end the trail once we hit the target. Then we render a VFX emitter with the same position that we have on the axe. The emitter will be the axis, and then you can add different settings. By the way, position Y is minus 0.3. And what we do is we spawn particles over time. Inside half a second, we will spawn 80 of them. We don't set any position, direction, or rotation because it will follow the one from our rigid body, its world position. This is something done automatically inside the VFX emitter. Let's try it. Start game. We can wait for the better score, and you can see we have a nice trail of our axe, adding more movement to it. Then for a better gameplay, we can add some SFX, sound effects. They are prepared in the app component. You have the audios here, pop, impact, and throw. They are preloaded. We simply need to connect them. Inside here, where we emit sparks, we also want to play audio. We use the positional audio component. We play the pop sound, autoplay, and loop set to false. We only want to play once. And distance to adjust the power of the sound. Be sure to do the different imports from dry. Now inside the impact, where we hit the target, we can add a positional audio with the impact one. And this one we will play it manually using a reference. Const sfx hit is equal to useRef. We want to play it directly on the intersection hit, and we want to be able to stop it and to play it. This way, if it was playing before, we stop it and we start it again. We also add another one when we throw the axe. By adding it here, it will follow the position of the axe for a nice effect. We create a reference for it. And when we launch the axe here, we also stop it. We also play the audio. Let's see what we get. Start game. We wait for a few balloons to come. I missed the target, but we could hear the explosion of the balloons. Perfect. One last thing is to adjust the camera for mobile game, because from here it's fine. Oh, we also need to lock the camera. But here we can see the target. First, we can disable camera controls by setting the mouse button and touches to 0. This way they won't perform any actions. And we can adjust more our camera. First of all, we can adjust it also if it's the first game or if we don't have any throws left. Now, if it is our first game, we will set it to a new position, to -15, -5, and 20. We need to import first game here and the number of throws. Now, the starting position of our game will be this, much more lovely. Now, if the axe is launched or if we don't have them anymore, we set back the camera to there. And for mobile, if the window size is below 1024, we can set a different camera position further away. Else, we do what we were doing so far. Let's try it. Of course, you could adjust this one. Let's start the game. This one we didn't adjust, but now we can move the axe without moving the camera. And from here we have a better visibility even on mobile. Thank you for watching. I can't wait to see what you will build with this new knowledge. If you enjoy this, don't forget to hit the like button and to check out the full VFX chapter in the course, link below. You will learn how to build this package and go 10 times deeper. To not miss the upcoming video tutorials, subscribe to my channel. And to continue your learning journey, watch this video, available here.